Welcome. My name is Scott Woodgate. Let's dive into Linux security and see how Azure can help you secure Linux. Quickly setting the scene, of course, we all live in a shifting world. I'm recording this from home, as you would expect. But more than remote work, conventional security tools just frankly haven't kept pace with the need to secure both what is in your data center in terms of all those Linux instances, as well as everything you have in the public cloud. And so customers are looking at new ways to secure not just their Linux, but their entire environments that support hybrid. And as you know, the cost of security breaches continues to incline. Attackers are still evolving on a regular basis. Regulatory pressures are high. So this is a really important topic, and it's very, very important that you understand, as you're thinking about security, how the other side works. As the defenders, how do the attackers work in terms of security? And while all of the focus in the press might be on zero-day attacks and the latest zero-day attack, the reality of the dark web and attack services on the dark web is it isn't 0 days, but it's more vulnerabilities that exist because of lack of customer following best practices for vulnerabilities that have been around for a long time that are actually far more important. And so there's some real key things that you need to do to take in mind this view of the cost of various attack services. You can see, ransomware is quite a lot cheaper than 0 day, or spear phishing quite a lot cheaper than 0 day. And one critical thing here is to focus on the hygiene of your systems. That's very, very important. And the second thing is to fundamentally focus on enhancing your identity protections with MFA and passwordless. To really take wind out of the sail of spear phishing attacks and compromised accounts. And then finally, the third thing is denial of service remains a thing, and so enabling DDoS is critical. So that's really the big picture of how the defenders work and some of the types of tasks that you really need to focus on when you're protecting. Now, in Azure, we live in a zero trust world. And what that means is we have a set of identities who are authenticated through conditional access that get access through policies to resources. There's an entire ARM backplane that is used to really ensure that the right user has the right access that is verified in the moment to the right technology. So zero trust is a fundamental architectural design point of Azure, which really does help you defend in this new environment. And of course, from a Microsoft perspective, the way that we think of security broadly is in these three buckets. How do we help you? The first one is, and you'll see this a lot today, built-in experiences. And so Azure has a lot of built-in security technology. And that built-in security technology works across platforms, both in the sense of course, works great with Linux, which has more than 50% share in Azure as well as Windows. But it also works in terms of supporting other platforms such as GCP or AWS. And so more and more we think of Microsoft as a security vendor to you as opposed to just protecting Microsoft's assets. And in the cloud, AI and automation are one of the key ways that we can help your resources scale. We know that there are not enough people focused on securing your organization today. And so we can use AI and automation to really help pinpoint the most critical issues and address those issues with the resources that you have. And then the other fundamental piece is, while we're really focused on Linux security here, you really need a security solution that is broad across all of your workloads, all of your people, all of your devices, and all of your applications. And at Microsoft overall, it is our perspective that we can provide that value to you. So let's dive a little bit deeper into security of Azure. And at first glance, this slide may be a little bit overwhelming, but the reality of security is you need to have a defense in depth approach. And you need to be thinking about security from all of the different aspects, whether it be the identity aspect with things like MFA and role-based access control and privileged identity management are critical aspects to it, through to the application layer, how do I manage my keys and certificates or even data, through to the network security layer with various firewalls and multi-segment networks and beyond that. Through to threat protection, constantly monitoring your sources, because the best laid plans are always require also monitoring to see if attackers are getting in. And then, of course, how do you manage all of this? And this is where I'll spend a good period of time on security posture management and so on. So all of these services are actually built directly into Azure, integrated into the framework of Azure. And we're going to touch on just a few of them today, but I want to make sure you're clear that we have a comprehensive approach to security, and there's certainly a lot more than I'll be able to cover in the short period of time we have today. So quickly with identity and access control. And as I mentioned before, MFA is just incredibly important. It's the number one thing you can do to help from a security perspective. So absolutely do that. And then the second piece is Azure, of course, has both role-based access control and conditional access. So make sure you set up the right roles to have access to the right resources in Azure. You know, your security people have access to Key Vault, which is our key store, but your management people don't, and your developers certainly don't, just as an example. And so step one in securing Azure is really taking advantage of MFA, conditional access, and setting up roles and access controls around that so that that zero trust framework that I talked to earlier is working in full force for you. The second piece you really need to focus on, and this is really the centerpiece of hygiene, as mentioned earlier, in Azure, is the combination of Azure Security Center and Azure Defender. And so Azure Security Center is really your one-stop shop for security in Azure. And it enables you to get what we call a secure score. And so the secure score gives you a numeric value that shows you how well you are following best practices on Azure. So for example, if your Ubuntu virtual machines are on the latest patches, if there are any issues in terms of vulnerabilities within applications, if there are issues with encrypting disks, setting up networks, and so on and so on, all of those best practices are listed under your secure score, and you get a numeric number on that. So if you're at 100%, you're perfectly secure with the best practices that we know of today. If you've got less than that, then you've got work to do to go improve that. And when you improve that, you can change one virtual machine at a time. That's fine if you're an application owner, but you can also apply policies at scale. And so, for example, you can turn on monitoring for all of the virtual machines that are running in your subscription using a policy. Or you could say there are no internet-facing endpoints coming from any of my virtual machines using a policy. And so there's this deep policy layer that helps you provide governance on top of that. And then built on top of that is automation in terms of notifying, auditing policies when they're out of compliance if you've made them auditable so that you can go address them. So it's one piece of Azure Security Center, which I'll demonstrate shortly. The second piece is the defense in depth piece of always monitoring the workloads. And so this piece is through the built-in feature of Azure Security Center we call Azure Defender. And Azure Defender is an XDR, an extended detection and response platform that protects all of your Linux virtual machines through active monitoring, as well as all of your other workloads, including networking, storage, even IoT and cloud native workloads if you're doing those in Azure. So the combination of these two, great hygiene and monitoring defense in depth, is critical for security in Azure. So with that, let's go do a quick demo of Secure Score in Azure Security Center. All right, here we are in Azure Security Center. So let's take a quick tour. Actually, the first thing I wanted to point out is, of course, we support all of your assets running in Azure, including your Linux VMs. But in addition to that, we give you visibility across AWS accounts or GCP accounts. So if you have assets in AWS and GCP and you want to understand the security posture of those, you can go to Azure and get a multi-cloud view all in one place in Azure Security Center. This is the main dashboard, and I won't have time to cover everything, but you can see we have a preset list here of regulatory compliance controls, and you can add additional ones if they apply to you. And we'll do a test to see what your security looks like relative to a set of policies that would be appropriate for HIPAA, PCI compliance, and so on. What I'm going to do now is dive into looking at a specific Linux VM. So I'm going to go into the inventory view. Now, of course, in my inventory, I have all types of things. I have virtual machines, I have PaaS services. You can see I've got an AWS account here that's hooked in. But in this particular case, I'm going to go search for a virtual machine for a project that I'm working on, which is actually Jenkins. And you can see in this view that Jenkins is monitored. So the way that Azure Security Center works is it installs an agent in the VM extensions in Azure for that virtual machine, and then uses that agent to pull information that it can build insight out of. And so I used a policy to actually set up that agent in Azure across my whole subscription. It just automatically installed into my whole subscription. And by the way, in addition to doing this multi-cloud, I can also use Azure Security Center to cover any of my Linux VMs that are on premises by installing that same agent in the on-premises Linux VMs and pointing it to Azure Security Center. So I've got the agent going and it's been running, and what does it show me? Well, here it is now giving me some great advice on things that I need to fix. So one of the biggest attack vectors beyond identity on any cloud presence is brute forcing of passwords. And it's hard to brute force passwords remotely unless you have your SSH ports open, because that's a common attack vector. And so this SSH password brute forcing is a big deal. And so Azure has recognized here that this particular virtual machine actually has its management ports open. So you can see that their management ports open, and then has a number of recommendations on that. One of the things that Azure Security Center has built in is this notion of adaptive network hardening, where we actually use machine learning to understand your behavior on that virtual machine. And if you put the SSH ports open, but you've never actually SSH'd in over a 3-week period, we assume that you should turn those off because it dramatically improves your security. And we'll prompt you that with our adaptive network hardening. So that's a key part of the overall equation. The second piece that I want to drive in here is vulnerabilities, because as well as things like disk encryption and management ports, with our built-in Qualys capabilities, we have all of Qualys vulnerability management. You can see a list of really specific issues. So for example, I'm using Jenkins, and I have the Jenkins Git client plugin running inside this Ubuntu VM. And in fact, I'm on a version that has a known vulnerability. And so we've prompted for that known vulnerability and have given you information on how to take remediation steps. So this is really, really helpful, because with all of the package dependencies in Linux and the fact that vulnerabilities are appearing all the time, you can use this as a guide of exactly what's running on your VM from a vulnerability perspective and fix it. Now, as I mentioned earlier, best practices, of course, are one thing, and you should follow all the recommendations. But the second key aspect to any security strategy is defense in depth. And that's where Azure Security Center has built in Azure Defender that is constantly monitoring your resources, whether they be your Linux or Windows servers, or as you can see here, all of the other resources. This shows me which resources are monitored and which aren't. So for example, I'm actually doing pretty good, but it looks like some of my key vaults are not monitored. I want to make sure I'm monitoring my key vaults from unauthorized access. And then we could drill into various areas, including specific attacks that may be coming on here that I need to address, and then go resolve those attacks quickly. So that was a very brief demo of Azure Security Center. All of this wraps up, just before I close, into something we call a secure score. And so you can see here across all of my assets right now, including my Linux virtual machines, I'm 61% protected. And if I was going broader than my Linux virtual machines, we actually prioritize the set of recommendations that you should do quickly to improve your secure score. And so you can see that remediating vulnerabilities in, it looks like 125 of my virtual machines, I have a fairly insecure subscription for demo purposes, is the first thing I need to do to increase my secure score by 9 points. Well, that's how Azure Security Center works. Now I'm thrilled to introduce to you Lech, who is from Canonical, of course, makers of Ubuntu, who's going to talk to us more about security from his perspective. Handing it to you, Lech.
Thank you, Scott. Hi, I'm Lech from Canonical. We are publishers of Ubuntu, the most popular Linux distribution. Developers love Ubuntu because it's much more than just Linux operating system. It is a trusted gateway to consume open source securely. Let me quickly explain what I mean by that. But first, let's quickly take a step back and have a look at the whole open source landscape. Open source today is everywhere, and it consists of about 70% of the code that is used by enterprise applications. The problem is that half of the open source being used contains known vulnerabilities. At Canonical, secure open source is at the heart of what we do. Together with Azure, we are raising security awareness and providing a more secure ecosystem for our users. To give you an example, have a look at this code analysis performed by SNCC. They looked into the top 10 official Docker images and found that in 2019, all but Ubuntu contained multiple known vulnerabilities. Many are surprised by these numbers. If the vulnerability is known and the patch is already available, why aren't those just getting patched? To understand that, let's have a quick look at the key security risks. Security starts with the initial configuration. Oftentimes, default configuration is focused on usability rather than security. For example, providing generic accounts with no strong passwords. It's done so that developers can have a quick start with a known config. Hardening is the process that enables strict security features for a given application or library to make it more resistant to a potential attack. Unknown software vulnerabilities are also a critical problem. If you look for open source software on GitHub, you will find that an average repository has over 200 package dependencies. Today, modern open source applications require a large number of software dependencies. These dependencies can in turn have their own dependencies, which creates a large number of dependent pieces. While the use of these dependencies allows open source application developers to develop faster and not having to reinvent the wheel, they present a security challenge for teams who wish to deploy those applications. A vulnerability in any given dependency could potentially be leveraged to exploit the application itself. So the security of the lifecycle of each dependency needs to be managed to ensure security. Finally, even if you track all vulnerabilities, for which Azure Security Center can be really helpful, you can fail to apply all necessary patches on time. IT teams and developers are often held up by the difficulty in prioritizing and automating security patching for a growing number of open source software packages used by enterprise workloads. At Canonical, we've been providing security patches for Ubuntu for over 16 years, during which we fixed over 12,000 vulnerabilities and on average applied critical patches in less than 24 hours. If you go to Azure Marketplace today, you will find many official Ubuntu images optimized for Azure, including Ubuntu Pro. Ubuntu Pro is a new, all-inclusive Ubuntu available today on Azure Marketplace. It comes with 10 years of security maintenance, full coverage for high and critical vulnerabilities, daily updates, and guaranteed upgrade path. It also includes FIPS 140-2 certified cryptographic modules for FedRAMP compliance use cases, and automation tooling to apply and audit CIS hardening to safeguard enterprises against cyber attacks. It provides comprehensive configuration checklists to identify and remediate security vulnerabilities, often recommended by HIPAA and PCI compliance in finance, telecom, and healthcare industries. CIS Benchmark has hundreds of configuration recommendations, so hardening a system manually can be very tedious. With Ubuntu Pro tooling, you can apply and audit your Ubuntu Pro in under 30 minutes. Ubuntu Pro also includes kernel live patch, which I will now quickly demonstrate for you. I just created an instance of Ubuntu Pro on Azure and I'm now going to SSH on it. Because Ubuntu Pro is updated daily with all the security updates, I'm actually using an old Ubuntu image from September 8th, 2020. So imagine that this is a VM that was running since September 8th without any reboots. Now, let me check the status of Canonical Live Patch to see if there are any security updates that were applied to the kernel. As you can see, there's a number of security updates that has been applied as live patches. Look how many CVEs have been fixed within a bit over 2 months. Please note that not all security updates can be applied as live patches. Nevertheless, live patch is an essential feature for large estates and critical workloads, which gives you an instant kernel security that works in the background so that you can achieve a fully patched Linux kernel controlled reboot cycle with no unscheduled reboots. So with that, please keep your VMs safe and talk to us to learn more about Ubuntu Pro. Thank you. Back to you, Scott.
Thanks, Dick. That was great. So we talked about zero trust up front, and we really focused on identity and conditional access, role-based access control, and so on. But the second part of zero trust is really on the network side. You need both. And so on the network side, it really starts actually on the right-hand side of the slide with how you build your network topologies inside Azure, which we typically do using network security groups and making sure you're using the right level of micro-segmentation so that you isolate various applications in a way that if one happened to be compromised, it wouldn't have a downstream flow through the remainder of them. So Azure has this concept of network security groups, and for PaaS services, also this notion of service endpoints, so that those PaaS services, if you choose to use them, are only on your virtual network as opposed to exposed to the internet, which are an important place to start. On the left-hand side, is a typical set of services that you'd expect. You know, if you are building a web application on Apache, then you need a WAF, and you certainly want DDoS protection. And you can certainly run those workloads inside Linux VMs using typical open source tools, no problem on Azure. But if you want to simplify your life, then Azure has actually built-in PaaS services that we run that you don't have to worry about the management and maintenance of patching, etc., in the Linux VMs. And just simply take advantage of turning them on and putting them in front of your Linux VMs. And so we have a PaaS service that is a DDoS service that obviously protects you from DDoS, a PaaS service that is a web application firewall. And then for your broad subscription, we recommend that every subscription in Azure has an Azure firewall, which is a traditional inbound, outbound filtering firewall, which can help protect you. So that's the second piece of zero trust in terms of networking. I recognize in this incredibly quick overview of Azure security, there's a lot of implementation details that aren't here. And I'd strongly encourage you to go listen to Mark Simos's 10 best practices on Azure security, where he takes you through more detail on this set of 10 best practices. We've covered a number of these today very quickly, including secure score, passwords, zero trust, threat protection, but there's a lot richer detail, both in terms of this presentation and prescriptive guidance that we have in our CAF, is what we call it, our Cloud Adoption Framework, as well as our well-managed content that we're putting out there. So this is just skimming the surface to give you a view. I really encourage you to go look for Mark Simos's great work there. Before we close, I have a couple more topics to cover, which are really specialized use cases at some level. The first one is confidential computing. And of course, in Azure, your data is your data, just as it is on premises. That is our promise to you. And historically in the computer industry, encryption has been applied to data at rest. I've stored something in a MongoDB. Data at transit, it's moving on the network. Oh, and by the way, we recently added double encryption to data in transit on Azure. However, once data was in the CPU in use, it's encrypted and visible to anyone, which could make it vulnerable to insider attack. Or there may be scenarios where you might want to share data with a trading partner, but for business reasons, but not necessarily have the trading partner actually see the data. So a good example of that could be multiple financial services companies getting together, definitely not wanting to share customer data, but wanting to be able to use that joint customer data to understand fraud that is happening. Because as you know, if you train machine learning on a bigger data set for multiple banks, it's more likely to spot fraud patterns than it is for a single bank. And that's just one of the many examples that would require confidential computing on the CPU itself. And so Azure uniquely, actually, as a public cloud provider, provides application-level confidential computing built on top of the Intel SGX technologies, so that you can run in application code and secure enclaves for many of the scenarios that are on this slide. So just one example of that is actually building confidential containers using the Azure Kubernetes service. You can also do this directly in Linux VMs, writing your own code, modifying apps to make them secure enclave aware. So to give us a demo of how this works, I'd like to now hand off to Amar.
Hi, my name is Amar Gowda. I am the product manager for Azure Confidential Computing. Today, in this demo, you will see how a customer who's running a sensitive application on Kubernetes is implementing an elevated security for containers enabled through confidential containers on using Intel SGX VMs. This customer is building a defense in depth container strategy, and the implementation with confidential containers is for one of their Python-based microservice application. A Flask-based RESTful API module is being converted to a confidential microservices with no overhead or changes to the code. The lift and shift path should also provide code integrity and data in use protection through Intel SGX. In this demo, you will witness how to add a Intel-based ACC nodes queue to Azure Kubernetes Service, take an existing Python app and make it SGX ready, and deployment to SGX nodes, and testing the application by calling the web API and operating this service itself. You are looking at an existing AKS cluster that has a standard node pool. And now I will switch over to a CLI to add Intel SGX-based DCSV2 VMs that give you the ability to run confidential containers. Before that, I will add an add-on that will make my life easy with deployments as well as the business continuity of these apps. This add-on is in preview, so you may have to use a CLI that has a preview extension. So once it's complete, now I'm going to go and add a DCSV2 node pool to the same existing cluster. You need to pass an additional header, use Gen2 VM, because DCSV2 VMs only support Gen2 virtual machines on Azure. So once complete, you should see an SGX plugin run, and you should be able to verify that by issuing a kubectl get pods command. I can see the device plugin as well as the code helper in this command. And they are up and running. So they mean they're only running on DCSV2 node. So let's switch over to a REST API simulation. So this is a standard node. And if you can see here, there is an external IP that I'm going to switch over to a postman to perform a HTTP post request. So this is simulating a PII-based microservices application that's taking in one parameter and responding you with JSON. So let's switch over to the code itself. So in this code, if you see a Python application, and this is a Docker file that is very simple and is leveraging an existing Python 3.8 based base image. So if you look at the app.py file, it's a very basic Flask web API application that accepts a JSON request, processes it, and creates a regular output with NumPy package. So I'm switching over to this other window that shows the deployment file for Kubernetes service. So it's a standard node listening on 4996 port. So this is the second YAML file. I'm showing a confidential container application, and I'm just comparing this to the other one that's showing the file is very similar. However, there are some additional attributes in the YAML file like EPC memory, which is very specific to SGX-based apps. Confidential containers is enabled through ISVs and an ecosystem of open source projects. Here in this case, I'm removing using Photanix, one of the ISV solutions. I take the existing Python Docker container, I put in some parameters and ask it to spit out a SGX-ready confidential containers. So once it's done, I go and deploy my YAML file that is specific to this image that was generated. So once the pod is up and running, I just go fetch the IP address of that file. And now I'm going to switch over to the other window to show you how exactly the same application running confidentially on SGX is made enable for the same Python Web API project. Now I have fetched the IP address of the confidential application, and I'm showing you in the Postman interface how I can send the same exact request and see a response back from the SGX confidential container application. In summary, you saw how lift and shift was enabled for an existing Python-based microservices, how standard and non-standard confidential containers were running side by side on the same AKS clusters, and how existing tooling was leveraged. This is the end of the demo. I hope you liked it. Please visit these links to get access to the samples and read more about confidential containers offering on Azure Kubernetes Service. Thank you.
So the final topic is really focused on the Security Operations Center inside your organization. And as you know, security operations doesn't think about individual resources, protecting Linux, protecting Windows, protecting SQL, protecting Mongo. The SecOps team is there to protect all of it. It's a big charter. And to do that, SecOps teams have historically used SIM tools that collect log files, for example, syslogs from all of your Linux machines across the entire enterprise, and then process those logs through query engines to understand complete kill chains that may traverse from an external website through to, for instance, a directory controller. And so Azure has the first public cloud to have a built-in cloud-native SIM, which is Azure Sentinel, that's had amazing customer reception with more than 7,500 customers in its first year. Azure Sentinel effectively imports logs from all of these sources and then has an artificial intelligence layer on top of it that uses machine learning to then identify for the SecOps the highest priority alerts wherever they are. And also builds visual kill chains. So SecOps can seize that. And of course, all the traditional things that you can do with a SIM, including advanced query language, are available in Azure Sentinel. And so once again, this is for your SecOps team. It's less about for your DevOps team. But I'd strongly encourage you to go look at Azure Sentinel. It's by far the easiest SIM to set up if you're used to on-premises SIMs, because it is effectively a software as a service. You literally go turn it on and start importing sources across Azure, which would include the sources for Linux VMs, across Microsoft 365, as well as across Barracuda, F5, Cisco. I could go on and on. As you'd expect, it's collecting data from your entire enterprise and therefore a broad set of partners. So in summary, Azure has a strategy to provide built-in capabilities in all of the key areas you need to protect your security infrastructure. And at this point, now many years into the strategy, a mature set of tools to help you get secure in Azure that are, in many cases, broader than what you may have had on premises. Now, with that being the case, we are an open ecosystem. And so, of course, we've collaborated with a broad set of partners, and this is just a small set of our MESA partners. And so you can use the first-party services, and I'd encourage you to, but your favorite third-party service for security also works just great in Azure. So with that, I'd encourage you to dive deeper, take a look at the Azure Security Architecture Guidance, take a look at the documentation, participate in the community. Thanks for your time today. Cheers.